Alright, today's topic is exponential functions. So exponential functions are graphs in the same terms of lines, but they're a little different. So, for example, when we have a linear graph, right, if it's linear, okay, then we have a straight line. So basically we have a line that is a straight line left, doing whatever it's doing, right? An exponential function, so if it's exponential, what that means is that our line kind of goes up at a constant rate, okay? So our line's going to look more like this. Okay. So instead of being a straight line where our slope or rate of change is the same each time, like, remember slope goes up, by 1 or 2 each time, exponential graph, it kind of goes up exponentially. The rate remains constant, so it's always being going up like this, or going down in the sense of a decay function. Okay, so with the linear line, our equation is y equals mx plus b, right? With an exponential equation, our equation is y equals ab to the x power. Okay, so this is the one that we're really going to be focusing on today. All right, is this stuff here, exponential functions, where we have a function that goes up or down, curves up or down, and our equation is y equals ab to the x power. Okay, and we'll get into that in this video. Don't worry about that. So first, let's figure out how we know if a function is exponential or not, and we're going to look at a table for that. Okay, so if we're going to make a table, all right, and we have like this, and we have x, and we have f of x, basically just y. Okay, input output, right? And we have 2, 3, 4, 5, right? Let's say our x goes up 1, 2, 3, 4, 5, 6. Okay, so it goes up the same, and our f of x goes up 2, 6, 18, 54, 162, 486. Okay, so now we're going to figure out, is this an exponential function? Okay, so the biggest thing to remember here is first you look at the x. Okay, does our x go up in the same rate? It does, right? It goes up by 1 each time. Okay, looking at our f of x, our output here, does it go at a constant rate? Okay, so is there a pattern? That's what we're looking for. Is there a pattern involved? Okay, so to figure that out, we're going to look at our numbers here, and we're going to take our first two numbers, okay, 6 and 2, okay, and we're going to divide the bigger number by the small number. So we're going to do 6 divided by 2, I'll just do it this way, 6 divided by 2, and that equals 3, right? Okay, so this is a factor of 3 here, okay? Excuse me. So we can say that 2 times 3 times 3, right, is 6, okay? Now if we do these two, is it the same? 18 divided by 6, right? So 18 divided by 6 also equals 3. So once again, this is a times 3, right? And then same here, right? 54 divided by 18 is 3, right? So each time, as we see these numbers, our smaller number is being multiplied by 3, okay? So 2 times 3 is 6, times 3 is 18, times 3 is 54, times 3 is 162, so on and so forth, right? So is there a pattern? Yes, there is a pattern, okay? And it's times by 3, right? Each time our rate goes up times by 3, right? So it's not, we don't want it to be like the same factor, right? We don't want it to be like added each time. We want it to be times, okay, each time it goes up. So is it exponential? Yes, it is exponential. Yes, exponential, okay, because it goes up at a constant rate each time. This is all the same right here, okay? So that's how you figure out if your data in the table is exponential, okay? So let's do another example. All right, and I'll leave I'll leave this here, and then I'm going to change these numbers here. Okay, so let's change these numbers, all right? Let's say 5, 13, 21, 30, 42, 50, right? Okay, so if we look at this and try to say, is our rate the same, right? Can this be multiplied by a number to get this number at the same number, so on and so forth, right? So if we do 13 divided by 5 to see if there's a pattern of 13 divided by 5, we can't do that, right? It doesn't work out. You get a decimal, right? Doesn't work. Same thing at 21 and 13. Nothing's going to work, right? The pattern is not the same, so there is no pattern, okay? So it is not exponential. Right? Not exponential for this one, okay? So there's no pattern here. There's no rate of change. It does not get multiplied each time going up or down or whatever. It's just random numbers, okay? So not exponential. All right, let's try another one. Let's do 800, 400, 200, 100, 50, 25. Okay, so now let's start here. I have let's go my bigger number. So this side hasn't changed yet. This is still up by 1. Let's go my bigger number here, 800 or 400. Let's divide that. If I do 800 divided by 400, I get 2. Okay, so we have a factor of 2 right here, right? And we're going to say it's basically going down by a half, right? If we multiply, it's multiplied by a half. So divide by 2, multiply by a half, it's the same thing, okay? And now if I do this one, 400 divided by 200, that also gives me 2, right? So going down by half, 200 or 100 by half, right? 100 or 50, it's all by a half, right? It all goes down by half each time, right? 400 is half of 800, 200 is half of 400, 100 is half of 200, right? So on and so forth, right? So it all goes down by half. So yes, there has a pattern, right? And it's times by 1/2, okay? Or you can say or divide by 2, okay? Same thing, right? Times by a half, divide by 2, right? So yes, this is exponential. Exponential, okay? So you can see how that works out, right? Let me do one more, and we'll move on. Okay. Let's go 5, 10, 15, 20, 25, 30. Okay. So now if we go look at this, right? We look at our f of x, right? Now our f of x this time, 5, 10, 15, 20, 25, 30, right? So we know right away that this goes up by 5. It gets added by 5 each time, right? But we don't want it to be added by 5, right? It needs to be a constant rate, right? So it needs to be like times by something to get this, right? So if I do this, 10 divided by 5, I get 2, right? So this is a times 2 here, right? If I do 15 divided by 10, I get 1.5, which is not the same, right? This needs to be the same number. So this is a times 1 times 1.5. So there's no pattern, right? We don't want this. We don't want a plus 5. We need to be a multiply or division case, right? So no, and this is not exponential, okay? So show you. So if it adds up to that, that's great, but we don't want that. This would be a linear function actually, not exponential. We want exponential function, okay? All right, let's move on. All right, moving on. So to show you, there are two basic types of graphs, right, of functions, right? So we have a growth, in which our line kind of does this and kind of goes up, right? This would be growth, okay? And then we have we have our function where it starts up here and kind of comes down like this, right? And this would be a decay. Okay, so growth goes up left to right, decay goes down left to right, right? So in this case, our equations are both the same. Y equals AB to the x power, okay? And in this case, B is greater than 1, okay? In this case. With decay, same equation, but in this case, B is greater than 0, but less than 1. So basically it's a fraction, okay? That's kind of what we're talking about, right? So B is greater than 1 for growth, B is greater than 0, but less than 1 for decay. So in this case, you know, our A would be anything bigger than 1, so 2, 3, 4, 5, whatever, 1.5, right? Decay would have to be some kind of fraction between 0 and 1, okay? So let's take a look, okay? So now, to figure out this, we need to plot, make a table, plot some points, okay? Do a little quick math and plot some points. So if we have a function, f of x equals 2 to the x power, okay? 2 to the x power, okay? Now, if we make a table of this, right? And alright, and same thing, we're gonna do x and y, right? X, and we're gonna do f of x, okay? So for the x coordinates, we're gonna pick any numbers to be our x to kind of plug in here to solve, okay? So what I always like to do is pick the same ones. We're gonna do 1, 2, 3, right? So we're gonna pick -2, -1, 0, 1, and 2, okay? So if I take these numbers, plug them into my x here, my answer will be in this set here, okay? So my first thing, I'm going to take this 2x, okay? And I'm going to put this x in this place, so 2 to the -2nd power, alright? And when I solve that, I get 1/4, okay? So my answer, 1/4, will go here, alright? Now I'm going to do the same thing with this one, 2 to the -1st, and that's going to equal 1/2. So 1/2. 2 to the 0 power would be 1. 2 to the 1st power would be 2. And 2 to the 2nd power would be 4. Okay? So I've solved out, all I did was take my x, plug it in here, okay? And then just solve it, 2 to the 2nd power. You can do this in the calculator, you can do it in your head, however you want to do it, okay? Now, if I were to graph this, okay, if I were to graph this here, then it's just my x and my y, okay? So in this case, my x is -2, so my x is -2, my y is 1/4, okay? So if that's 1, it's probably like right here, right? And then -1, it goes up a little bit, right? At 0, we're at 1. At 1, we're at 2. At 2, we're at 4, right? So if I connect my dots, then that's my function, okay? So that's how you do it. All right, take your x, plug it into the x it gives you to get your y's, and then plot it on the points. X and y, plot it on the points, okay? Let's do another one. So let's do f of x is 4 times 1/2 x, okay? Oh, sorry. 4 times 1/2 x, okay? So if I make my chart again, okay, x, f of x, 1, 2, 3, 4, same numbers, -2, -1, 0, 1, 2, okay? So, once again, I'm plugging it in. All right, I'm plugging in my -2 here for my x. So I have 4 1/2 to the -2nd power, right? So when I solve this, I do this is going to equal 16, okay? So 16. And then I'm going to do 4 1/2 to the -1st power. That's going to give me 8. And then 4 to 0. That's going to give me 4. 4 1/2 to the first gives me 2. And then 4 1/2 to the second gives me 1. Okay. So I'll plug these numbers in, 8, 4, 2, 1, all right? And let's say you can do this on a calculator, it's fine. 1/2 the second power and then times it by 4. 1/2 to the -1st power times by 4. 1/2 to the 0 power times by 4, right? You can do that on the calculator. So now when I draw my graph here, I plot my points, right? So x -2, so -2, 16, right? So that's way up here, right? I'm not even going to bother to draw that one, okay? Because it's going to be way up here. -1 and 8, so if I do 1, 2, 3, 4, 5, 6, 7, 8, right? So -1, 8, and then at 0, 4, 1, 2, 3, 4, 1, 2, and 2, 1, right? So now this line is coming down here like this. Okay. So now we have a decay here. So this would be a decay model, right? Because it's going down, right? The one before it was a growth because it was going up. This one is going down, so it will be decay. Okay. So once again, you have your function. You're taking your x's, you're plugging it into the x in the equation to solve for your y or your f of x, and then you're plugging it in on the graph, plotting points, and graphing.